Hello, good afternoon, good day, good morning, whatever time of day you are viewing this. This is Professor Campbell, and I am back. Today, we are going to continue on with finding the LCD of rational expressions. Now, we left off last class where we were finding LCD, and we're going to continue because it's a little bit more than what we did on last class. Because as we continue to find LCD, we are soon going to be adding and subtracting. Okay, so let's get started, shall we? All right, I'm going to share my screen. I hope you all have been reviewing the videos that came prior to this, because it does help, so much so. I know last time we had some technical difficulties with the pen. I hope the pen plays nice today. If not, I will just have to change over, and I think I'm pretty flexible. I can do this. All right, first we need to draw. So let's get some writing ink, shall we? Okay, come on, let's go. Let's start with purple today, shall we? Okay. Finding LCD, continue. Find LCD of rational expressions. All right, let me review something that we did last class. It's simple. Oh, I'm on the wrong page. I'm adding already. I'm like, no, we're not there yet. Okay, okay, here we go. We have 5 over 6x cubed, and we have 11 over 8x. 11 over 8x squared. Oh, it's going to be to the 5th. Oh, come on, not today. See, let's do it again. How can I be sure? Rational expressions is what I like. I have to entertain my class, so while we're going up through this a hiccup, let's just think positive. Okay. Okay. All right, thank you. Back to the marker. Okay, we have 6x squared and 8x to the 5th. We're actually find the LCD. The first thing you want to consider is your coefficients. My coefficients are 6 and 8. You ask yourself, what is the smallest number that both 6 and 8 can divide into? Now, you can ask yourself that question, or you could count by 6s, which is basically the multiples of 6, and count by 8s. So I think for most of us, that might be the easiest way to do it. So let's count by 6s, shall we? 6, 12, keep going, 6, 12, 18, 24, 30, 36. Let's count by 8s, 8, 16, 24, 32. Okay, what number did we say as we listed both multiples? Okay, we said 24. So 24 is going to be my numerical coefficient. So 24. So 24. So my GCF it's going to be 24. That's going to be my GCF for my numerical part of my denominator. Then I'm going to ask myself, what is the GCF for my variable? And remember, the GCF is going to be the larger exponent because you can always build up to it. I can go from x cubed to x5. So here again, I told you this last class, the LCD, we find LCD, the GCF, the exponent is a larger exponent. Why? Because if I was to write, let me show you why that is true, correct. Okay, so I have, oh gosh, this would be a 5. So I have 5x cubed, oh, 6x cubed, and I have 11 over 8x to the 5th. And I'm saying that my LCD is 24 x to the 5th. My LCD is 24 x to the 5th. That's what my LCD is. Now, it couldn't be x cubed because that means I'd have to go from 5 down to 3 if this was x cubed. So it makes sense it would be the larger exponent. That means I can work my way up from x cubed to x to the 5th by using the product rule for exponents. So here again, in LCD, it cannot be x cubed because that means I'd have to take this x to the 5th and go down. And I cannot do that. But with the product rule, I can go from x cubed to x to the 5th. Now, let's go ahead and work it out, shall we? Now, in order to get from 6 to 24, I'm going to multiply by 4. In order to get from x cubed to x to the 5th, I'm going to consider the product rule. The product which says we add exponents. So what plus 3 gives me 5? That's a 2. And remember, whatever you do on the bottom, you have to do on the top because we're basically making equivalent fractions. Now I come down here. What times 8 gives me 24? Of course, it's 3. And because x to the 5th is already there, that will not change. So I don't need that because if I was to write it here, that's going to make it increase. So I don't need to put the x to the 5th here as part of my equivalent fraction. But I do need to put the 3 up here because whatever you do to the bottom, you have to do to the top. So now let's go and multiply. 5 times 4 is 20. And of course, x squared just comes right over. Here, 6 times, you can't see that. Where are you? 6 times 4 is 24. X cubed times x squared is x to the 5th because we add exponents because of the product rule. In the bottom fraction, we have 8 times 3, which is 24. And here again, I do not need x to the 5th here because then it would give me x to the 10th. So x to the 5th simply becomes part of my denominator by default. And so I'm going to multiply 11 times 3, which gives me 33. So if I needed to add these two expressions, I could, because I now have an LCD. But that is why my LCD is 24 to the 5th. And it also explains why my exponent is going to be 5 instead of 3, because I can work from 3 up to 5, but I can't go from 3 down to 5. Okay? From 3, I can't work from 5 up to 5. All right, so let's look at, and we also looked at one that looks like this. We have 3 over x and 6 over x plus 4. Looking at both denominators, they have nothing in common. And when they have nothing in common, you simply multiply to get the LCD. when denoms, I call them denoms for short, when denoms have nothing in common, multiply to get the LCD. Multiply to get the LCD. Multiply both. So in this case, if the direction says find the LCD of each pair, my LCD will be x times x plus 4. That's all the direction actually do, find the LCD. And that's all we do. Multiply x times x plus 4. And that will be the LCD for those two because they have nothing in common. So I'm going to do what the notation says. When denominators have nothing in common, multiply both to get the LCD. And that's all we do. Okay, now we're going to step it up a notch. We're going to have a little bit more going on in our expressions. Okay, let's see what we have here. Okay, we have 6m squared over 3m plus 15. And we have, 2 over m plus 5 squared. Now, this is where you really are going to be challenged to understand the different steps. My first denominator is 3m plus 15. My second is m plus 5 squared. All right. The easiest way I can suggest is to do these two things. The first thing you want to do is factor each denominator. Factor each denominator. Factor each denom. Look for which factors are in common. Look for common factors. Look for common factors. All right, I'm going to do that part first because the next part you have to actually be at that point to do what I'm going to say next. All right, let's factor the denominator. Here again, we're only focusing on the denominator because right now all we're doing is finding the LCD. So I'm going to look at my first denominator. I have 3m plus 15. I need to factor out the GCF. I know 3 and 15 are both divisible by 3, so that means I can factor out a 3. I'm going to take out a 3 as my GCF. And let's see what's left in my parentheses. 3 divided by m divided by 3 is 3. 15 divided by 3 is 5. So I factor the first denominator. Now, m plus 5 squared is a product because that tells me that m plus 5 is being multiplied by itself. So that means that in factored form, it would be this, m plus I. So I factored each denominator and I'm going to look for common factors. What common factors do I see in both? They both have an m plus 5. So that's what I did right there. I'm looking for the common factors. So yellow, yellow. Look for the common factors. Once I find the common factor begins the LCD. Begins LCD. In other words, that's the first part of my LCD. So I know my LCD is going to have a m plus 5 in it. I know that's part of my LCD. Okay, I factored each denominator. I identified a common factor they had in both. That common factor begins my LCD. It's only written once because they both have it. They both have it, so it's only written once. Now, as I look at my problem, what is left? In this one, I have the 3 left. In this one, I have this left. Now, this is the way I state it, so it makes a little bit of sense. Here again, I like to talk layman talk. I don't talk mathematical because students get more confused because you're confused why they come to you for help, and then you still talking over their head. So I try to take it down a notch. So at this point right here, each denominator and here again I'm abbreviated, will oh God, what's that word? Give what's left to the LCD, left to the LCD, to the LCD. All right. Let me get some markers I can highlight so I can see. Okay. This right here is what's in green. All right, let me go back so it makes sense. Okay, so I factored each denominator. You see that in orange. Then I identified the factor that they both had that was the same by highlighting in yellow. Once I identified it right here, I wrote the first part of my LCD. The common factor begins your LCD. Now I highlighted green. Each denominator will now give what they have left to the LCD. So the first denominator has n plus 5 left. I'm just gonna have 3 left. So that becomes part of the denominator. The second fraction has n plus 3 left. Excuse me, n plus 5. That becomes part of LCD. Now to make it nice and pretty, normally the 3 comes first. And because you have n plus 5 repeated, you can write it as a binomial square. Oh goodness, I say square, I'm getting rid of it too. I don't know why it's not erasing. I'm not going to worry about it. All right, we know that's the 5. And of course, we're going to square. So that's my LCD. 3 times n plus 5 squared. That's the LCD. So we factor that out. Assuming we factor the denominator right here. Right here. We identify what they had that's the same. N plus 5. That becomes the beginning part of my LCD. What's left in this denominator was 3, so that they're going to contribute the 3 to the LCD. This denominator is going to contribute what's in green. So my final LCD is 3 times n plus 5 squared. Now those steps are too simple. Here again, you're going to really need to pay attention to those steps as the problems become more and more involved. All right, let's do another one, shall we? Let's see if we can pick it up a notch. How about one where we have trinomials? That ought to be fun. Okay, let's see. We have t minus 10 over t squared minus t minus 6, and we have t plus 5, t plus 5 over t squared plus 3t plus 2. All right, what's the first thing we need to do? Factor the denominator. First thing we do is factor. So we're going to factor the first denominator. Because there's no leading coefficient, it's very easily factored into TMT. We're going to factor 6. The two factors of 6 is going to give me 1, it's going to be 2 and 3. Now, because I need a -1 in the middle, my bigger number needs to be negative, so I'm going to do that. Now we're going to factor the other denominator. Here again, there's no coefficient in the front, so that factors the 2 and, T and T. Now, if 2 is a prime, it only has 2 factors, 2 in itself, 2 and 1, excuse me, and everything's positive, so we know it's going to be positive. So I'm following the steps that I wrote above. Factor first. As I observe, I notice they have t plus 2 in common. So because they have t plus 2 in common, that's going to be the start of my LCD. T plus 2. So what I do, once I've used them, I cross them out because they've already played their role. They've gone to the next level. The first denominator has t minus 3, it can contribute to the LCD. So whatever is left from each denominator is contributed as part of the LCD. Whatever is left or whatever remains is contributed to the LCD. And it's okay that you have a crazy LCD like that because it'll happen. Here again, you just find the LCD, so that's all to it. What does not make sense? I think if you follow those steps, it should be pretty self-explanatory. Are any questions or concerns? Okay. Let's move on. Okay, the next one we have here is 2 over x minus 2 and 10 over 2 minus x. Now. Who can tell me what you notice? If you notice, we talked about this before, these are opposites. These are opposites. So guess what? We can make them the same. And because you commonly see a expression written where the variable comes first, which means we need to do something with the 2 minus x. So we have x minus 2. You have 2 minus x. What can I do to make them the same? Here, that's x minus 2, where my x is positive. Here's just 2 minus x, where my x is negative. So to make it positive, we can take out a -1. And when we take out a -1, we're basically going to make x going to be positive and 2 is going to be negative. Or otherwise, you're simply multiplying by a -1. Remember, whatever you do to the top, you have to do to the bottom. Yeah. Now, guess what? Like I said, it's commonly written where it's this way, but if you did it the other way, where you switch this one around, then it's fine as well. But it just forced a habit as a math instructor to do it this way. But this will be my LCD because I took out that -1 right there. And as we move on, you'll see how the -1 will be affected. Will affect the numerator, but right now, this is my LCD. Yes, no, maybe, tell you tomorrow. Okay. Now, let's move on to the next thing. The next subtopic is going to be finding or writing equivalent rational expressions. Writing equivalent, and I did one of these examples when I first started because I want to show you why what I was saying about exponent makes sense. Writing equivalent rational, I'm going to abbreviate expression. All right, let's go. Okay, we have 4b. Y'all tired of seeing purple? Let's change it, shall we? Okay, I have 4b over 9a. And it's equal to 27 a squared b. So in other words, it's actually to find out what's the missing numerator. And that's what we're going to be doing once we start adding and subtracting. That's what we're going to be doing, finding the missing numerator. So here we are preparing for that next step. We learn how to find the LCD. Now we're preparing to find equivalent expressions, knowing that we have to find a missing numerator. Okay, so here again, let's take a look. We're just going to work with the denominator for right now, and then we'll come back up to the numerator. Okay, the numerator is 4. You have 9a. And they tell you that that equals to 27a squared b. So you're trying to get from 9a to 27. And when you do that, they're going to be equal fractions. So you ask yourself, what times 9 is going to give me 27? Of course, 3. I'm trying to get from a to a squared. Here again, the product rule comes into play. And if we multiply a times a, we're going to get a squared because we add exponents, which give us a squared. Now, we need a b over here, but there's no b here, but we do need to put a b here so we can make sure that we're getting there. Now, here again, it all suggested that you check along the way so you can know you're on the right track. So let's check, shall we? 9 times 3 equals that 27 that they gave us. A times a is a squared. And then we have b times 1 is b. And we're making equivalent fractions, so whatever you do to the bottom, you have to do to the top as well. So on the bottom, I have 3ab. On the top, I also need a 3ab. Now we can get a new numerator. 4 times 3 is 12. A, B. So 4 over AB is equivalent to 12AB over 27AB squared. Finding equivalent fractions. I worked on my denominator first because I need to find out what number that I need to multiply both fractions in order to get my equivalent fraction. All right, we're going to try another easy one. You want to jump on in? Easier jumping. Easier jumping. Which one? Okay, you jump on in. All right, let me see which one I want. Okay, here we go. We have 7x over 2x plus 5 equals 6x plus 15. Now, there's more than one way that you can do this problem. And I said when we first started this lesson from lesson 1, factoring is going to be important. Factoring is going to be important. Now, some of us can probably look at it and say, oh, I know what's missing. The question is, how did they get from this? How did they get from 2x plus 5 to this, right? That's your question. One way you can do it is to factor. Here again, I know that word some of us just hate. Factor, factor, factor. Oh, well. The factor a denominator. So let's factor. What goes into both 6 and 15? 3. So let's pull out the 3. Leave with 2x plus 5. Once I've done that, I now see that they have 2x plus 5 in common. So in order to get to 6x plus 15, they had to multiply the original denominator by 3. So in order to get your new numerator, that is exactly what you're going to have to do. So we have 7x over 2x plus 5. And here, let me change color so I can have a contrast. Now, here again, we're saying that if they multiply this by 3, that means I have to do the top by 3. And we're going to check. 3, of course, this is the expression, so it needs to be in parentheses. 3 times 2 is 6. 3 times 5 is 15. So that's how they were able to come up with 6x plus 15. They multiplied the denominator by 3. So that means we have to do the exact same thing on the top, 21x. So 7x over 2x plus 5 is equal to 21x over 6x plus 15. Finding equivalent rational expressions. Okay. Is there a challenge yet? Ooh, okay, yes, there is. Okay, there's one more challenge. I'm trying to do one of each level. The first one had monomials, the second one had binomials. Now we're going to move on to a little bit more challenge. Charlotte, darling. Excuse me. Okay, we have 5 over x squared. Oh, not x squared, I'm sorry. Yeah, x squared minus 4. Minus 4. Ding, 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 ding. What do you see? What do you see? Okay, we have here x minus 2, x plus 2, and x minus 4. That's the denominator that you're given, and you have to find equivalent rational expression. What's the first thing I told you to do on the other page? Factor, factor, factor. Now, when we get rid of factor, what do you notice about your denominator? It's difference of squares. And remember, difference of squares factors into sum and difference. Difference of squares factors into sum and difference. You put your parentheses, you put your plus and your minus sign in there, you're good. Now you can take the square root of each term. The square root of x squared is x. You put 1 in each parentheses. The square root of 4 is 2. You put 1 in each parentheses. So we factored. So we do this factor. Now, this is what I share with students. You ask yourself, what is in a new denominator that's not in the old denominator? What factor is in the new denominator is in the new denominator that's not in the old denominator? Here again, I am speaking layman terms because it's kind of easier for you to see what I'm trying to get you to see without having to make it complicated in my verbiage. What is in a new denominator? Meaning the equivalent fraction that we're looking at, that's not in the old one. It's not in the old. That's not in the old. Okay, my old denominator is, after factored, it's x plus 2, x minus 2. This is my new denominator. This is my new denominator. So if I look in comparison, what is in green that's not in orange? Excuse me, what is in orange that's not in green? X minus 4. So in order for them to get this denominator right here, they had to multiply the green by x minus 4. So that means that's what I have to multiply the top and the bottom by. So this is what it should look like. What I'm calling it. Okay, I'm going to So we have 5. We have 5 over, I'm going to write the green form of the denominator instead of the original. X minus 2 equals, okay, x minus 2, x plus 2, x minus 4. So when I wrote my factored form of my old denominator, I noticed that they're almost the same, but they're missing what? This one doesn't have an x minus 4. So I need to multiply that by x minus 4 in order to get the new denominator. That means I need to do it up top as well. So now you know the denominators are the same, but I need to go ahead and multiply. Sometimes they do and sometimes they don't. Distribute 5x minus 20. And this is your answer. The question was find equivalent fraction and they were missing the denominator. Now I'm going to recap again, slowly so it can make sense. The first thing I did was I factored my denominator. I noticed it was difference of squares, and I know that that's sum and difference. Then I look at the denominator that they gave me, and I look at my factored form of my denominator. I notice that the green did not have an x minus 4. So that is telling me that that is what they multiplied x squared minus 4 by in order to get that long denominator. So I rewrote the x squared minus 4 in its factored form right here. And now I'm multiplying my numerator and my denominator by that missing factor. Notice when I do that, I have the same denominator on both sides. And here I distributed. That's how I got 5x minus 20. Because 5 times x is 5x, and 5 times 4 is 20. And so my answer is 5x minus 20. But here again, these little tidbits make sense. You factor what is in the new denominator, but not in the old denominator, x minus 4. So that's why both the top and the bottom number, numerator and denominator, are being multiplied by x minus 4, so I can find my numerator that the question is asking for. Yes, no, maybe, did that make sense? Because we're really getting ready to rock and roll now. We've learned how to find LCD. Now we're actually going to put that to work as we add and subtract rational expressions. All right, let's get some more paper here. So we're going to add and subtract the rational expression with unlike denominator. Add and subtract rational expressions with unlike denominators. Okay, here we go. We're going to start simple. We're going to do one where they're just regular numbers, and we're going to go to some algebraic fractions, and then we're going to go into the fun part. Okay, first example. Okay, I've seen enough green. Let's break the monotony. Okay, we have a over 4. And we have as minus 2a over 8. All right, a over 4 minus 2a over 8. Suggestion: find your LCD first, identify it, and then put it in its place. Once you do that, then you could worry about making equivalent fractions. We have denominators 4 and 8. We know 4 divides into 8. So because 4 divides into 8, LCD is 8. And the smallest number 4 and 8 can go into. So LCD is 8. Now that we've done that, we can now create equivalent fractions. Here again, remember we're going from one to the other and they have to be equivalent. Let's focus on the denominator. Let's do the bottom fraction first because it's simple. In your beginning problem, 8 was already part of the denominator. Therefore, you do not have to change it. Because you don't have to change the denominator, the numerator will not change. So that will remain 2a. Now, the top number, if your LCD is 8, we had to get to 8 some way. So you say to yourself, what times 4 gives you 8? 2. And remember, whatever you multiply times the bottom, you have to do it times the top as well. Oh, that was a tricky one. Okay, what's 2 times a? 2a. Sorry, this is a tricky one. Remember, in fractions, you only combine the numerators. So when I come out into my answer, I know 8 is going to be there regardless. And here, say it's a tricky one. You rarely see these kind of problems in math. All right, 2a minus 2a, of course, is what? 0. And you should have learned whenever 0 is in the numerator, the answer is going to be 0. So that is that. I'm sorry. I didn't know they was going to trick us like that. Let's try another, shall we? 3 over 10 x squared plus 7 over 25 x. X, okay. All right, like I said, we have 10 and 25. Let's find the LCD, shall we? All right, let me change colors again. Okay. They both end in 5, they end in 5 and 0. We know 5 can go there, so that means they're multiples of 5. Or if you know how to count by 25, then to count by 10s, but you should know money with the LCD, the coefficient LCD. 50. And I'm going to write my coefficient LCD, which is 50. Now, we know they're going to have an x in there. Remember, at the largest exponent is part of your LCD. The largest exponent is part of your LCD. The largest exponent is part of your LCD. Because I can build up to something, I just can't build down. You can't build down, you break down. All right, let's see. We're trying to get to 50x squared. So let's see, what can we multiply by 10 that's going to give us 50? 5. We do not need an x there because if we do, we're going to increase our x's and it's supposed to be x squared. So remember, when you multiply times the bottom, you have to do it times the top as well. What times 25 is going to give me x? Excuse me. What times 25 is going to give me 50? 2. I need an x squared. So what can I multiply my x by to give me x squared? X. Because x times x is x squared according to the product rule. Multiplying like bases, you add the exponent. And whatever I do to the bottom, I have to do it to the numerator as well. So now let's do it. Let's double check before we go to find our new numerator, shall we? Where are we? 10 times 5 is 50. And because there's no x here, my x squared just comes over as part of my LCD. 25 times 2 is 50. X times x is x squared, so I know I have done that correctly. So now we need some new numerators. 5 times 3 is 15. 7 times 2 is 14x. Now, excuse me. Ladies and gentlemen, let me come up a little bit. put numerators together as one expression. Together expression. Put numerators together as one expression. So my numerator up top was, let me scroll down a little bit because I lost it. Okay, 15 plus 14x. 15 plus 14x all over 50x squared. Notice this is an expression. You cannot combine 15 and 14 because they're unlike terms. Unlike terms do not combine. Unlike terms do not combine. Do not add. 15 and 14 cannot be combined, and you cannot cancel the x's because remember that plus sign is a stop sign. The plus sign is a stop sign, so that means you can't cancel the x's. If you see a stop sign in front of a number like that, that's what it says, stop. So by putting the numerators together, you see you have an expression, and we are dealing with rational expressions. And because 15 and 14 are unlike, they're not added, and our answer is 15 plus 14x over 50x squared. All right, are you with me still? Hang in there, we're doing good, we're doing good. All righty then, are we ready to get our party started? Okay, we have 6x over x squared minus 4. And I like to write mine vertically, like I said earlier in one of the lessons, so you can better see what you need to do. You have more space to work out your problem. It's x plus 2. All right, the first thing we want to do is factor where possible. Now I see, excuse me, I see that my my top denominator can be factored, so I'm gonna factor that. X plus 2, x minus 2. And think about it, students. Once you factor, that's the denominator you want to focus on. Don't worry about the original one, which was x squared minus 4, because right now we need to work with the factored form. I factored. Now I see that I'm going to identify common factor. Identify common factor. Identify common factor. So here again, we're looking at what's in red because we're not paying attention to this one anymore because that can't help us the way it was. So we made it where it's identifiable and it can help us get our LCD. So looking at this denominator in red and the denominator of the bottom rational expression, what do they have in common? And I see, said the blind man. I'm sorry, I had to throw that in there. What they have in common to me is x plus 2. So earlier we said whatever they have in common starts my LCD. So I'm going to put x plus 2 because that's what they have in common. Whatever they have in common starts your LCD. They have x plus 2 in common. So once I have identified what I have in common and they're no longer effective. Once I have identified what they have in common and I wrote it as part of my LCD, I am done with the x plus 2. So whatever remains each denominator, and I said this earlier, but I didn't say the what I'm saying now because I couldn't remember how I used to say it. Each denominator will contribute, there you go, will contribute to LCD. If they have nothing to contribute, then they don't have anything to contribute. Now, if you look at the top fraction, x minus 2 is not crossed out. So x minus 2 can be contributed to the LCD. So we can go ahead and add x minus 2 to our LCD. The bottom fraction, on the other hand, it has nothing to contribute, and that's okay. We have our LCD. We identified a common factor which started our LCD. Then whatever was left, each denominator contributed what they had left to the LCD. Now we need to find equivalent fraction like we did earlier by finding a new numerator. Here again, ask yourself, what's in my LCD that's not in this over here? What's in my LCD that's not in my old denominator? In this case, there's nothing there that's not there. So that means my LCD was my original denominator here once in factored form. So we're good. Down here, what is in my LCD in yellow that's not over here? What is in my LCD that's not over here? X minus 2. So that's why I need to multiply the top and the bottom line. Now, you're not literally multiplying the bottom because the bottom's already been multiplied. That's how you got an LCD, but you still need to show it. And when you show it, you can see that you're going to see the LCD. Now, back up at the top, because I didn't need to multiply anything up top because my LCD was already there, that means I would just bring my numerator over. Okay, so let's go ahead and distribute that 3, shall we? That's 3x minus 6. Right here. Remember, this is a, shucks. This right here is a minus sign. All I did was bring it over. Because what I'm going to do now is the next step. So my top numerator is 6x. Here's my minus sign. Here's my minus sign right here. And I have 3x minus 6. All over my LCD. And I get lazy until I just write the word LCD. But since I'm being broadcasted, I'm going to be good. Who can tell me what happens here? We did this last class. Let me help you out. Let me put in a darker color so you can know what's going on. Distribute the -1. Distribute the -1. Remember, there's an imaginary 1 right here. So we need to distribute that -1. In other words, does it mean you multiply whatever in the parentheses times -1, or everything in the parentheses becomes its opposite. So once we do that, we now have 6x minus 3x plus 6. That's what my numerator looks like right now. And I can combine like terms because 6x and 3x are like terms. I can combine them. So I now have 6 minus 3 is 3 plus 6 over my LCD, which is x plus 2, x minus 2. Now, you're not finished until you have simplified. If you would notice, while adding, there's no simplifying in the midst of the problem. There's no simplifying at the beginning of the problem. When it's added and subtracted, all the simplifying happens at the end. So at this point now, we need to simplify, but we need to factor first. So we're gonna Factor to simplify. Factor to simplify. So if I look at my numerator, I can factor out a 3. I'm going to pull out a 3. I'm going to lower some, write my denominator first. X plus 2, x minus 2. So I'm going to pull out a 2, excuse me, a 3, leaving me x plus 2. I now have factors in my numerator. And because I have factors, I am able to cancel. I can cancel x plus 2 and x plus 2. Once I do that, I'm left with an answer of 3 over x minus 2. And that's my final answer. So that was a handful. But guess what? They get a little bit more complicated, but the process is the same. So we started with what's in blue, and we went through this whole process, and I gave you little tidbits as I went by step, and our final result is 3 over x minus 2. All righty then, good job. Okay, now we talked about if two denominators had nothing in common, how you find the LCD? By multiplying the 2. So let's do one example with that concept. So we have, whatever my 2 over 3t plus 5 over t plus 1. Okay, we have 3t and t plus 1 as our denominator. They have nothing in common. I can't pull out anything. I can't make nothing out of something out of nothing. So here again, this is one of the cases I talked about earlier in the lesson. When they have nothing in common, the LCD is basically the two denominators being multiplied. Nothing in common, so I would multiply both denominators to give me the LCD. Nothing in common, so multiply both denominators to get LCD. Nothing in common. Multiply okay, they have nothing in common, so I'll multiply both of them to get my LCD. All right, so you're going to do the same thing we talked about before. You ask yourself, what is in the new denominator, but not in the old denominator? Of course, t plus 1. T plus 1 is in the new denominator. So in order to get a new numerator, we have to multiply both the top and the bottom by t plus 1. Okay. So we're going to multiply times t plus 1, t plus 1. Down here, what is my new denominator? What's here, but not here? 3t. So that means we got to multiply the top and the bottom by 3t. And if you would notice, what I'm trying to get you to see, once we're multiplying, notice what I see here is what I see over here. And that's what the objective is, to make sure that this denominator looks like what's here once you do your multiplying. And same thing down here. I have 3t times t plus 1. I have 3t times t plus 1. So let's go ahead and multiply and distribute. 2 times t is 2t. 2 times 1 is 2. 5 times 3t is 15t. Write one numerator. Put them together. So that's 2t plus 2 plus 15t. I took both my numerators and wrote them together, knowing that my denominator is not going to change. So I need to make sure that I'm putting my numerator together correctly so I can combine like terms if possible. Combine like terms if possible. And I do have like terms. I have this and this are like terms because they both have t. And when I combine them, I get 17t. So if you write 2 plus 17t or 17t plus 2 is the same thing because of the commutative property. So either way is correct. Commutative property says so. So I have 3t times t plus 1. Now, as I get to this point right here, and I notice that all my numbers, whether it be coefficients or the constants, they're all prime. So there's no more factoring. There's no possibility of canceling. That's all I can do with that. Because I have a whole bunch of prime numbers going on and they have nothing in common. So there's nothing that can be pulled out that's the same. All right. How is that? Now I have one more fun example. And it has to do with opposite. We talked about that earlier. We have 7 over x minus 3 minus 9 over 3 minus x. All right, it says be observant. Be observant. Now, we did one of these earlier. Notice that the denominators are opposites. And I like my x minus 3 first. I'm sorry. So what I want to do is, first of all, I'm going to take out a negative here so I can make that x minus 3. So let's do it, shall we? So we have 9 over, I'll pull out a negative 1. And when I do that, here again, layman talk, this is going to flip. And let me tell you why it flips. Okay, let me tell you why it makes sense. You see that negative 1 that I pulled out? Here again, I'm pulling it out because I wanted it to look like the denominator on top. But you can tell you did it right because if you were to multiply negative 1 times x, what do you get? This negative x right here. Negative 1 times negative 2, what do you get? It's 5 to 3. So you know you did it correctly. So let's go ahead and bring over this 7 x minus 3. So right now they have LCD. Now let's go ahead and write one numerator and be careful. We're writing one numerator. Here's my 7. What kind of problem was it? A subtraction problem, right? Here's my subtraction problem. I mean my subtraction sign. That negative sign that I've got pulled out is still there. I'm gonna highlight the sign that's the same. Let me get some highlight going. This and this is the same. Remember, a negative sign does not affect a numerator and not a denominator. It affects the whole thing. So basically when I do that, I'm just telling you that fraction is negative. And it's all still over x minus 3. So the highlighted green is the same sign. It's a negative sign that was pulled out. The highlighted yellow is your operation sign. The operation sign has not changed. But what I need you to notice, you have double negatives, and I tell students all the time, double negatives, pay attention. Right here, double negatives. And double negative basically means so now you can combine the numerator because they're both constants. 7 plus 9, of course, is 16. And we denominator stays 7, x minus 3. Voila. Okay. Yes, no, maybe it doesn't make sense. That was pretty simple, wasn't it? The main thing to remember, students, when you see opposites, and here again, I like to put the x first. All I did was pull a -1 from each one of these, and they basically became their opposites. Here, 3 is positive. Here, it's a negative. Here, x is negative. Here's a positive. And at -1, if I was to multiply it back, it would give me what I started with. But the reason why I put a -1, because I'm trying to make the denominators the same. And the -1 that I pulled out, it is right here. It's in green. You can't just throw it away. It's still there. Okay? And my subtraction sign is highlighted in yellow. And I know that I have double negatives, so 2 double negatives make it positive. So I just use my imaginary dotted line and make them positive. 9 plus 7 is 16, and that's my final answer. Hope this is, I'm trying to make it make sense, make it simple. So I really hope that it's working out for you. All right, I think I got one more. You want one with a long denominator, or you don't want any gray here today? Let's see. Okay, let's see. Ow. 2 over 2x squared plus x. That's my first one. It's a minus problem. Oh my goodness. Yvonne, what are you looking at? It's a 3. See, we have to go up and down, up and down. Oh, your eyes tend to wander. What's wrong with my eraser? Not cooperating with this Campbell. Okay. We're just going to exit that out. We're going to start over. So it's 3 over 2x squared. My bad. I had a wrong number there, and it's not working with Campbell, plus x minus 2x. This is what the 2 is. Over 6x plus 3. Well, the first thing we need to do is factor each denominator. So let's do that. So 3 over, I'm gonna factor out an x, leaving me with 2 plus x. I'm gonna check before I go on. 2 times x is 2x squared. Got my x right here. Oh my goodness, come on, eraser, work with Miss Campbell. Why won't you erase? I don't understand. See, one, oh, there you go. Okay. Thank you, thank you, thank you, thank you, thank you, thank you. All right, let's go back to, okay. That should be 2x plus 1. My apologies. Let's check it. See, that's what you see how I can find my mistakes because I'm checking myself. X times 2x is 2x squared. X times 1 is x. Now the next denominator is a 2x. I'm going to pull out a 3, so I'm going to pull out a 3. Give me 2x plus 1. So factor. That's always the key. I factored. Now the next thing told you to identify the common factor. What's a common factor? This is a subtraction problem. The common factor is x, excuse me, 2x plus 1. 2x plus 1. That's what they both have. So that starts off my LCD. 2x plus 1 starts off my LCD because that's what they have in common. I'm crossing it out because it's already done its job. Look at what's left in each denominator. Each denominator is going to contribute what's left to the LCD. All right, the top denominator has an x left, so it's going to contribute an x to the LCD. The bottom denominator has a 3, so it's going to contribute a 3. So that's what I said when I mean contribute. You can't just have it and not use it. It is part of the denominator. You're looking for the common denominator. You're looking for everything that's in common. So now, let's look at our top denominator right here. What is here, but not over here? What is in this denominator, but not in the original? I know, I see it. I see a 3. 3 is here, but it's not over. So that means that's why I need to multiply the top and the bottom by. The 3 is in the LCD, but it's not in the original denominator. So that's why I'm multiplying the top and the bottom by. So that means I'm getting 9 as my numerator here. Now, what's in this denominator that's not in the original? I see an x next to the 3, so that's why I'm going to multiply my top and my bottom by x. So my new numerator here is 2x. And again, it's a subtraction problem, so we're going to write it as such. Did I copy that wrong? Oh, did I forget an x up top? Let me see. I think I forgot. Oops, there's an x right here. My bad. That's 2x. I forgot my x. So when we could subtract, because 2x is a term, we know it cannot be combined with 9. So let's write our numerator as one numerator. Now we're multiplying like, right here, we're multiplying like basis, x times x. The product rule said we're going to add exponents, that's going to give us a 2x squared. And of course, my LCD stays the same, which is 3x times 2x plus 1. There's no canceling because I see a stop sign right here, and I see a stop sign right here. Only these two, these are factors. But I cannot cancel the 3 and the 9 because 9 is a subtrahend. It's not a factor. It's in the middle. It has a stop sign next to it, so you cannot do any canceling. So that is the answer to my problem. You have to make sure you're taking conscious of what can be canceled, what cannot, and make sure that you're knowing what are factors and what are not. Okay, I'm gonna do one more problem, and it's gonna be an end. That'll be it for this lesson. It's gonna be a doozy. All right, let me get some paper. I hope I have enough paper left. No, I do not. And I can do it right here. Let me see if I got enough room. If I start up here, maybe if I start up here. All right, this is the last problem with this lesson. Hopefully I got enough room to get it all in. What color should we go out on? Let's go out on red. Okay, here we go. We have, I'm gonna start up here, it's 2x over x squared plus 2x plus 1. And that is being added to, I'm gonna write it right here. And when I get ready to do it vertically, then I can use my paper. X over x squared minus 1. The key is always to do what first? Factor, factor, factor. All right, so let's factor. And now I'm going to write it vertically so we can see. We have 2 over, I think it's a perfect square trinomial. What do you think? is a binomial squared. A perfect square trinomial is a binomial squared. And that's a binomial squared right there because you're multiplying the same expression by itself. In my other rational expression, it's difference of squares. Yeah. And we have talked about it so much, and you should know by now. Difference of squares factors into sum and difference. Square root of the first, square root of the second, and one's going to be minus and one's going to be addition. So now we're ready to find an LCD. We factored. We're going to identify what they have that's the same and what they have that's the same, please. They both have x plus 1. So that starts my LCD. Whatever they have in common starts my LCD. That's x plus 1. Okay, so once I'm going to cross it out because I know it has given its service. The top expression has x plus 1. It wants to contribute to the LCD. I'm going to give its contribution. And the bottom fraction has x minus 1. It wants to contribute. Phew. Now, what's the question? What is here, but not over there? X minus 1. And I'm going to get a different color so we can see the difference. So in my LCD, what I have my LCD that's not in my original denominator is x minus 1. So that's why I'm multiplying both the top and the bottom by x minus 1. What's in my new denominator at the bottom that's not in the old one? X plus 1. And here again, if you pay attention, once I write what's missing, the LCDs now look the same. I'm assuming the denominators look the same, the LCD and the original denominator. So now we're going to distribute. So we have 2x minus 2 in my numerator up top. And in the bottom, we have x squared plus x. So let's put, it's an addition problem. Let me see. Yes, it is. So we're going to put our numerators together. That's 2x minus 2 plus x squared plus x. All over my LCD. Right now, I'm going to just write the word LCD until I combine. I'll combine like terms. I can combine 2x and x, which gives me 3x. And because it's a polynomial, and in polynomials, it's usually written in descending order. So I'm going to have x squared plus 3x minus 2. All over x plus 1. X plus 1, and x minus 1. Now, at this point right here, we need to see if factoring is possible to see if we can simplify. So let's see, can we factor the numerator? I don't know. Let's see. We want to get a 3 in the middle, and we need a negative 2. Yeah, positive 3. I'm going to cheat because it's almost sounding good. You cannot factor it because there's no way you can get 3 in the middle. So our answer would be right there. Okay. All right, ladies and gentlemen, we have done a lot tonight. The next lesson we're going to be doing will be solving equations. We've been dealing with rational expressions. Now we can put them into equations. We're going to be solving those. So I want you to brush up on your factoring. If you're still having trouble, review what we have here. And we're going to start looking at solve equations on our next lesson. And I look forward to it. And I hope you have a good day and you stay safe. And I will stop sharing my screen right now so I can say a proper goodbye. This is Professor Campbell, Wintermester Camp at San Antonio College. You have a good day, and I will see you again. Goodbye.